Hi guys, and welcome back. In this video, we're going to talk about the vertebral column as it houses the spinal cord and it's considered an important part of the nervous system. Now let's talk about the vertebral column. So the length of the vertebral column, it's actually the bony part that houses your spinal cord because you guys know that we have the central nervous system is the brain and the spinal cord. They are very important structures. This is basically the electricity of your body. This is the control units. You need to house them in bony compartments to protect them. Exactly the same idea of the lungs and the heart that are protecting in the thoracic cage. So vertebral column is housing the spinal cord as it runs in the vertebral foramen, and the length of the vertebral column is 72 centimeters, and it has 33 vertebrae. It has 7 cervical, cervical, cervical in Latin means neck region, and then here you have the 12 thoracic vertebrae, and then you have of course, thoracic means chest, and then the lumbar is this is your lumbar region. It's related to your pelvis, and then you have the sacral. You have the fused sacral, 5 fused sacral, and then you have the 4 fused coccygeal. All right, this is basic information. Okay, and I drew this arrow because I wanted to tell you guys that as you go down in the vertebral column, everything is gonna be bigger. It's gonna be heavier. It's gonna be bigger because the weight is more. If you are lifting your head, it's gonna be lighter than if you are lifting your head and thoracic cage and upper limb. It's gonna be lighter than if you are lifting your everything above. So it makes sense that the vertebrae are getting bigger and thicker and heavier as you get down, all right? Now, what is the structure of the vertebra? It's very important you understand the basic structure of the vertebra before we go ahead and distinguish between the different parts of the regions of the vertebral column. Now, what is the basic structure of any vertebra? You have a body, and the body has, and this is your body, the vertebral body, all right? You have a body, and then you have the neural arch. The neural arch, why do we call it neural arch? Because it is an arch around your neural tissue inside. The neural tissue is actually your spinal cord. What is the neural arch? The neural arch is it's actually having the two transverse processes. Process means a process. It's an elevation, and it runs transversely. So we have two transverse processes. We have one spinous process directed backwards or downwards. It's at the back, so it's a spine. It's a spinous process, and we have between them the laminae. Okay, it's a layer of bone that connects the processes together. So the neural arch is showing us two transverse processes and one spinous process. Perfect. And this is the body. What about these two? These are the pedicles. Remember, guys, in the previous video, we said that pedicle means a foot. So if your body wants to stand on something, that is gonna be your feet, right? So the pedicles are actually the pieces of bones that are going to connect your body of the vertebra to everywhere else. So that way, that will make your life easy and remembering and differentiating, because that used to confuse me when I was a student, the pedicles and the laminae. One information is that your body needs to stand on feet. So these are the pedicles. Another information is that the laminae is very important. The lamina is one and laminae is plural. And the lamina is very important because this is a piece of bone that connects the processes together. And if there is a disc prolapse, if a patient has a disc, this is the disc, and we're going to talk about the discs later. And if there is a disc prolapse that is bulging at the back and it's affecting the spinal cord that is running in the vertebral canal, all right, if I have a disc prolapse, what the surgeon is going to do is he's going to cut these laminae and he's going to remove this part because he's going to do something called laminectomy. Laminectomy means, ectomy means cutting, laminae means your lamina here, 1 and 2, and that is because he wants to do decompression, because the spinal cord runs in the vertebral canal. And if I want to release that, because if my disc is here and it's bulging and compressing the spinal cord, giving me neural symptoms and problems, I need to decompress. I need to remove the pressure on the spinal cord. How can I do that? Is by cutting these two laminae. All right, so remember that these are the laminae. This is where we can do the laminectomy, all right? And that is by removal of this piece of bone and decompressing on the spinal cord, all right? I think now the vertebra is a piece of cake. We can go ahead and see more information about the vertebral column. Now, if I have a group, stacking groups of vertebrae on top of each others, I need to connect them together. So we will have two things that will help me to connect these vertebrae together. I have the vertebral bodies, and the intervertebral disc between them is going to connect them together. And I have the pedicles. Remember, you guys, your pedicles? Your pedicles are your feet, the vertebral feet that is going to connect the vertebral body to the neural arch. The pedicles, guys, it's gonna show you an articular surface. I have superior and inferior articular surfaces. Why? Because the superior articular surface is going to, if I have here a pedicle, I have superior articular surface that will help me to connect my vertebra to the inferior articular surface of the superior vertebral pedicle, right? So if you guys look at these vertebrae, can you guys see? Here we have all of these pedicles showing the superior and inferior articular surfaces. And if I have that, the articular surfaces, superior and inferior, they are going to connect the adjacent vertebrae together. And here I can have a column. I can have a connected column. Okay, so I have connection between the bodies. I have connection between the articular surfaces. And these are what we call the facet joints. I call them the zygapophyseal joints. All right, so these are the facet joints between the pedicles. And once I form the pedicles between the superior and inferior articular surfaces, I'm going to have the intervertebral foramen. Why do we need a foramen? Because you guys, we need to have the spinal nerves exiting from them. Remember, when we looked from above, the spinal cord is here, and I have bodies connected together, and I don't have any space. If everything was connected even from here, how would I get the spinal cord out of this? The only way is that if I have a connection between the superior articular facet of the pedicle and the inferior articular facet of the above one, I'm going to convert this space into a foramen. Can you guys see all these intervertebral foramina? All right, can you guys see all these spaces? Can you guys see all these spaces? All right, here I'm going to have my spinal nerves coming out, because this is the spinal cord. And when I have here articulation and down articulation, I'm going to convert into a foramen where I can have exiting of the spinal nerves. Okay, from here, the spinal nerves are going to exit the vertebral canal. Okay, so the vertebral what? Canal. This is a canal. The vertebral canal is bigger. The vertebral canal houses the spinal cord. The spinal cord, it's a cord, it's big, it's in the canal. However, the intervertebral foramina here, which was formed when we had communication between the facet joints, converting this into a foramina, that is going to be for the exiting of the spinal nerves. So the spinal nerves, right and left, are going to exit through the intervertebral foramina. All right,